In the aftermath of the Second World War, American defense planners confronted a strategic paradox that would define mobilization doctrine for the next 4 decades. The United States possessed the world's largest industrial base and an unmatched continental transportation network. Yet the transition from peacetime equilibrium to wartime output required not only economic scale, but synchronized activation of rail corridors, factories, manpower systems, ports, and federal authority under compressed timelines that Cold War contingency scenarios increasingly measured in days rather than months. And it was within this context that mobilization exercises, collectively referred to as MOBEX, were designed as deliberate stress tests of the domestic mobilization architecture, structured to move beyond theoretical war plans and instead impose simulated emergency conditions on the continental United States, forcing railroads, manufacturers, reserve units, procurement agencies, and port authorities to operate at surge tempo, while planners measured performance against quantifiable benchmarks embedded in reinforcement doctrine. And unlike overseas exercises that evaluated transatlantic lift or forward reception capacity, MOBEX began at the source of national power, examining how rapidly heavy armored vehicles could be assembled into military trains, how quickly civilian factories could suspend commercial production and retool for defense output, how efficiently reserve soldiers could be processed through mobilization stations, and how effectively federal authorities could translate statutory emergency powers into coordinated action across privately owned infrastructure. Because by the 1960s and 1970s, intelligence assessments indicated that a Warsaw Pact offensive in Central Europe might unfold with limited warning, requiring U.S. heavy divisions and sustainment flows to deploy within 72-hour and 5-day windows. And this compressed warning environment meant that domestic systems would have to absorb shock instantly rather than gradually. And early MOBEX iterations revealed that aggregate economic strength did not automatically equate to immediate military readiness, particularly in the rail sector, where the United States relied on commercial freight carriers operating near high utilization across key corridors connecting Midwestern depots and industrial centers to East Coast embarkation ports. And when exercise planners inserted simulated priority military trains into these corridors at rates required to move brigade-equivalent equipment sets within narrow windows, marshaling yard congestion, crew allocation constraints, locomotive availability limits, and bridge and tunnel choke points quickly emerged as pacing factors, demonstrating that throughput capacity was determined not by total track mileage, but by node efficiency measured in cars sorted per hour and trains dispatched per corridor per 24-hour cycle. And these empirical findings forced recalibration of time-phase deployment data to reflect realistic rail density rather than optimistic scheduling assumptions, while industrial conversion stress tests exposed parallel vulnerabilities as prime contractors tasked with surge production of armored vehicle components, munitions casings, communications equipment, and other defense items discovered that retooling civilian assembly lines required acquisition of specialized tooling, retraining of skilled labor, and reconfiguration of supply chains whose Tier 2 and Tier 3 subcontractors were often single-source providers lacking redundancy, and MOBEX evaluators timed the interval between mobilization notification and first accelerated output, measuring production ramp-up curves in units per week, and comparing them against projected wartime replacement requirements derived from attrition models, often finding that optimistic conversion timelines embedded in planning documents underestimated the complexity of synchronizing procurement approvals, quality assurance inspections, raw material acquisition, and workforce expansion, and manpower mobilization procedures were similarly scrutinized, with reserve activation throughput measured in personnel processed per mobilization station per day, revealing that documentation verification, medical screening, equipment issuance, and security clearance confirmation could create administrative bottlenecks even when manpower availability was abundant, and these stateside stress tests underscored a foundational truth of Cold War strategy: that the continental United States itself constituted a critical operational theater whose rail networks, factories, ports, and administrative systems had to function as a synchronized mobilization engine, capable of translating national economic depth into deployable combat power within the decisive opening phase of a potential superpower conflict. And therefore Operation Mobex evolved into a comprehensive, diagnostic framework that subjected transportation corridors, industrial plants, reserve activation centers, and federal coordination mechanisms to repeated, escalating stress scenarios, embedding empirical realism into mobilization doctrine and shaping infrastructure investment, priority routing agreements, subcontractor diversification strategies, and processing capacity expansion across the final decades of East-West confrontation. As Mobex scenarios grew more sophisticated in the late 1960s and early 1970s, planners deliberately shifted from evaluating individual mobilization components in isolation to imposing simultaneous activation across transportation, production, and manpower systems, recognizing that real-world conflict would not permit sequential adjustment, but would demand concurrency at scale. And therefore, exercises began with simulated presidential emergency declarations that triggered activation of reserve units, invocation of priority production authorities under the Defense Production Act, and issuance of rail movement directives within compressed hours, forcing federal agencies, state authorities, and private infrastructure operators to react in parallel rather than in sequence. And rail congestion quickly emerged as the most visible structural constraint, because heavy equipment movement depended on flat cars capable of carrying tanks, armored vehicles, artillery pieces, and engineering assets whose weight and dimensional limits required careful routing across bridges and tunnels, and Mobex controllers inserted military train requirements into already dense commercial schedules across corridors linking depots in the Midwest and South to embarkation ports on the Atlantic and Gulf coasts, measuring yard dwell time in hours, locomotive allocation intervals, and crew availability in shifts per day. And data revealed that classification yards near major metropolitan nodes often reached saturation when multiple military trains converged within narrow windows, creating cascading delay that pushed arrival at ports beyond planned loading sequences. And these delays were quantified in terms of hours lost per train and translated directly into sea-lift departure slippage, demonstrating how domestic rail congestion could ripple into overseas reinforcement timelines, while industrial conversion stress tests ran concurrently required factories producing civilian machinery, automotive components, or electronics to suspend commercial output and initiate defense contracts, with evaluators recording retooling lead times measured in days or weeks, depending on tooling complexity and workforce retraining requirements. And subcontractor mapping exercises revealed that a significant portion of surge delay originated not at prime assembly plants, but at smaller specialized suppliers lacking stockpiled raw materials or redundant production lines, meaning that a single delayed delivery of precision machined parts could halt entire production runs, and manpower mobilization was tested under these same concurrency conditions, with reserve call-ups issued to large formations and processing stations required to validate records, conduct medical examinations, and issue equipment at throughput targets expressed in personnel per hour per lane, revealing that administrative staffing levels and facility layout directly influenced activation speed, and port integration analysis further compounded stress by requiring that heavy equipment trains arriving from inland depots be sequenced into roll-on, roll-off loading slots without exceeding staging yard capacity near docks, measuring vehicle loading rates in vehicles per hour and container lift cycles in tons per crane operation. And by forcing these subsystems to operate simultaneously under compressed mobilization directives, MOBEX exposed systemic interdependencies that paper planning could not capture, leading to revised priority routing agreements with rail carriers, expansion of staging, areas near ports, advanced contracting with critical subcontractors, and modernization of mobilization processing centers, embedding empirical throughput data into Cold War readiness doctrine, and reinforcing the understanding that national mobilization effectiveness was defined not by aggregate economic strength, but by the synchronized performance of rail networks, industrial supply chains, manpower systems, and embarkation infrastructure under crisis tempo. By the mid-1970s, MOBEX planners began integrating mobilization stress testing directly with NATO reinforcement timelines, aligning stateside surge performance with overseas deployment requirements embedded in time-phased force deployment data. And this integration forced a precise comparison between domestic throughput capacity and the arrival benchmarks required to reinforce Europe within the first operational week of a Warsaw Pact offensive. Because heavy divisions stationed in the continental United States could only deploy if equipment reached embarkation ports on schedule, ships departed within convoy windows, and personnel activation matched transport availability, and therefore rail congestion analysis was refined to measure corridor density in train pairs per day, locomotive pool availability, and yard classification capacity in cars processed per hour under sustained surge conditions, revealing that while national rail mileage appeared ample, specific junctions near Chicago, St. Louis, and major East Coast gateways acted as structural choke points where limited switching capacity or crew shortages created multi-hour bottlenecks that cascaded downstream. And these findings prompted negotiation of pre-designated military priority routes and identification of alternate corridors to distribute load during emergency activation, while industrial conversion stress tests were expanded to incorporate munitions production modeling tied to projected combat expenditure rates, requiring factories to demonstrate how quickly output could scale from peacetime baseline to wartime targets expressed in rounds per week or components per batch, and evaluators tracked not only production ramp-up, but shipping synchronization, ensuring that surge-produced materials could enter the rail system without adding to congestion, and manpower mobilization analysis was further refined through throughput benchmarking at activation centers, where processing lanes were timed for documentation verification, medical clearance, and equipment issuance, establishing performance standards measured in personnel per hour and highlighting that administrative delay rather than manpower availability often defined readiness speed, and port throughput modeling incorporated vehicle staging capacity, roll-on, roll-off ramp availability, and crane lift cycles to ensure that heavy equipment arriving by rail could be loaded within vessel departure windows without dockside backlog, and the cumulative effect of these integrated tests was the identification of mobilization as a synchronized chain whose pacing element could shift depending on stress distribution, sometimes rail congestion, sometimes industrial conversion delay, sometimes administrative processing lag, and by quantifying each node's capacity and failure threshold, MOBEX transformed Cold War mobilization planning from a largely theoretical exercise into a data-driven systems analysis that aligned continental transportation networks, industrial surge capacity, manpower activation procedures, and port operations with the precise timelines required to sustain overseas combat operations during the decisive opening phase of a superpower confrontation. As the late 1970s transitioned into the early 1980s, and NATO adopted more aggressive operational concepts that assumed high-tempo conventional conflict in Central Europe, Operation Mobex intensified its focus on sustained mobilization rather than single-cycle activation, because planners recognized that the decisive question was not whether the United States could surge once, but whether it could maintain elevated output and transport density for weeks under simultaneous domestic and overseas strain. And therefore, later, Mobex scenarios extended beyond initial activation windows to simulate continuous rail dispatch, ongoing industrial production escalation, repeated reserve call-up waves, and successive port loading cycles, forcing subsystems to operate at high utilization over time rather than achieving a short-lived peak. And rail stress testing under these sustained conditions measured not only initial dispatch speed, but cumulative corridor fatigue, including locomotive maintenance intervals, crew rotation limits, and yard backlogs that accumulated when multiple heavy trains were sequenced through constrained nodes over successive days, revealing that throughput degradation often occurred after the first 72 hours due to equipment wear and scheduling compaction, and industrials. Conversion modeling similarly extended into multi-week production curves, assessing whether factories could maintain accelerated output without supply chain exhaustion, particularly in the case of precision components requiring specialized alloys or electronic parts whose availability depended on limited suppliers, and Mobex evaluators tracked inventory depletion rates for critical raw materials and compared them against replenishment timelines, identifying vulnerabilities in material stockpiling that could throttle surge production after initial ramp-up, while manpower mobilization exercises simulated staggered reserve activations, measuring the administrative capacity to process successive waves without backlog accumulation, often finding that documentation and medical screening systems were optimized for single-event activation, but required staffing reinforcement to sustain multi-week intake, and port throughput under sustained load was measured in vehicles per hour and tons per day across multiple departure points, revealing that dockside congestion increased when rail arrivals outpaced vessel turnaround cycles, prompting recommendations for expanded staging zones and improved loading choreography. And by subjecting the continental mobilization apparatus to prolonged stress rather than isolated activation bursts, Mobex revealed that endurance under surge conditions was as critical as initial speed, embedding into Cold War planning the understanding that rail networks, industrial supply chains, manpower systems, and port facilities had to sustain synchronized elevated performance across extended operational timelines if the United States was to reinforce and sustain Allied theaters during a protracted conventional conflict. By the mid-1980s, Operation Mobex had evolved into a layered analytical instrument that fed directly into national defense infrastructure policy, because the repeated identification of structural bottlenecks in rail corridors, supplier, networks, and mobilization stations prompted not only procedural reforms, but targeted investments designed to increase surge elasticity and rail congestion studies, which quantified throughput limits in trains per corridor, per day, and yard classification rates in cars per hour, led planners to identify specific high-risk nodes whose failure or overload would disproportionately affect national deployment schedules, resulting in the development of contingency routing plans and standing agreements with major rail carriers to allocate locomotive pools and crew shifts under emergency activation, while industrial conversion analysis influenced procurement strategy by encouraging maintenance of minimal peacetime production lines for critical defense components rather than complete reliance on rapid civilian-to-military retooling, thereby reducing conversion lead time measured in weeks and stabilizing production ramp curves under crisis conditions, and subcontractor mapping exercises uncovered single-source dependencies for items such as precision bearings, electronics modules, and specialized castings, leading to diversification efforts and stockpiling policies intended to prevent cascading delay if one supplier faltered, and manpower mobilization throughput benchmarks expressed in personnel processed per lane per hour prompted expansion and modernization of activation facilities, including improved documentation systems and increased staffing pools to accelerate verification and equipment issuance, and port integration reforms addressed staging congestion by redesigning embarkation choreography to better synchronize rail arrival with vessel loading windows, reducing dwell time, and aligning vehicle throughput with roll-on, roll-off ramp capacity. And the cumulative effect of these MOBEX-driven adjustments was to transform continental mobilization from a loosely coordinated assemblage of commercial systems into a more deliberately synchronized architecture, capable of translating statutory authority and economic depth into measurable deployment speed, reinforcing a central Cold War strategic insight: that the credibility of U.S. commitments abroad rested as much on the performance of inland rail junctions, factory assembly lines, and mobilization centers as on the strength of forward-deployed forces, and by embedding quantitative throughput data into planning doctrine. Operation MOBEX ensured that mobilization readiness was grounded in empirical stress testing rather than abstract economic optimism. In its later phases, Operation MOBEX also incorporated coordination with federal emergency management and state-level authorities, recognizing that large-scale mobilization would intersect with civilian infrastructure demands and potentially disrupt commercial economic activity. And therefore, exercises simulated not only military surge, but the ripple effects of reprioritized rail traffic, redirected industrial output, and concentrated manpower movement on regional economies, requiring coordination between the Department of Defense, the Department of Transportation, the Federal Emergency Management Agency, and state transportation and labor offices. And rail stress tests included scenarios in which civilian freight was partially displaced to accommodate military priority, measuring the economic impact in delayed shipments and assessing how long such displacement could be sustained without destabilizing supply chains for essential civilian goods. And industrial conversion exercises examined the trade-offs between suspending consumer production and accelerating defense manufacturing, calculating workforce redistribution and retraining requirements while tracking output loss in civilian sectors, and manpower mobilization simulations accounted for the sudden absence of reservists from civilian workplaces, prompting evaluation of continuity plans for critical industries. And these broader stress tests underscored that mobilization was not a purely military event, but a whole-of-nation transition requiring careful balancing of defense urgency with economic stability. And the data gathered during these integrated exercises revealed that legal authority under emergency statutes had to be complemented by pre-coordinated implementation frameworks to prevent confusion or duplication of orders, particularly when multiple agencies sought to direct the same transportation or industrial resources, and communication protocols between federal command centers and private infrastructure operators were refined to reduce decision latency from hours to minutes. Recognizing that mobilization timelines embedded in Cold War reinforcement doctrine left little margin for administrative delay, and by embedding civilian agency coordination into MOBEX design, planners expanded the concept of readiness beyond rail throughput and factory output to include governance capacity, ensuring that mobilization under crisis conditions could proceed without systemic breakdown or misallocation of critical assets, and thus, by the late 1980s, MOBEX represented a comprehensive rehearsal of continental surge, encompassing transportation, industrial conversion, manpower activation, interagency coordination, and economic impact modeling within a single stress framework calibrated to support overseas operations during the decisive opening phase of a potential superpower confrontation. By the final years of the Cold War, Operation MOBEX had become a mature instrument for measuring whether the continental United States could convert peacetime equilibrium into synchronized wartime output under compressed timelines aligned with NATO reinforcement doctrine, and its enduring significance lay in the systematic exposure of structural friction points that might otherwise have remained concealed behind aggregate economic statistics, because repeated stress testing demonstrated that national power was constrained less by overall industrial capacity than by nodal congestion, supplier fragility, administrative lag and interagency coordination gaps, and rail congestion analysis quantified the limits of key corridors and classification yards in trains per day and cars per hour, leading to pre-designated military priority routes and contingency rerouting frameworks designed to preserve deployment timelines under surge. While industrial conversion drills revealed the importance of maintaining warm production capability and diversified subcontractor networks to compress retooling intervals and stabilize production ramp curves under emergency demand, and manpower mobilization, throughput benchmarks reshaped reserve activation infrastructure to ensure that personnel processing rates matched transportation availability rather than lagging behind it, and port integration reforms aligned inland rail arrival with embarkation sequencing to minimize dockside congestion and sustain vessel departure schedules, and coordination, with civilian agencies strengthened the governance framework necessary to execute mobilization authority rapidly without destabilizing essential economic flows. And taken together, these empirical findings embedded realism into Cold War mobilization doctrine, demonstrating that the continental industrial and transportation base had been rigorously tested to sustain rail density, production acceleration, manpower activation, and embarkation throughput across extended timelines, ensuring that in the event of major conflict, the United States could translate economic scale into operational reinforcement within the decisive early phase of superpower confrontation, even as geopolitical transformation in 1989 and 1991 rendered full activation unnecessary. When viewed in full across the Cold War era, Operation MOBEX stands as the domestic mirror of overseas reinforcement exercises, a sustained effort to ensure that the continental United States could function as a synchronized mobilization engine under crisis tempo rather than as a passive reservoir of potential power, and through repeated escalating stress tests, it translated abstract assumptions about rail capacity, industrial flexibility, reserve readiness, and port throughput into measurable performance data tied directly to deployment timelines expressed in days and weeks, demonstrating that heavy brigades could not embark for overseas theaters unless inland rail corridors sustained required train density without classification yard saturation, that factories could not replenish munition stocks unless retooling intervals were compressed and subcontractor supply chains diversified, that reserve formations could not activate on schedule unless administrative processing lanes moved personnel at rates aligned with transportation windows, and that embarkation ports could not load vehicles efficiently unless staging areas and loading choreography matched inland arrival curves, and by forcing these systems to operate concurrently under simulated emergency directives, MOBEX revealed that mobilization effectiveness was defined by the slowest node in a complex national chain, prompting targeted infrastructure improvements, contractual priority agreements, expanded processing facilities, and refined interagency coordination protocols that strengthen surge elasticity across transportation and production sectors. And although the Cold War concluded without the activation of full national mobilization, the legacy of Operation MOBEX was a data-driven understanding that American mobilization readiness had been rigorously examined and adjusted to ensure that rail networks, industrial conversion mechanisms, manpower activation systems, and port infrastructure could sustain synchronized high-tempo performance during the decisive opening phase of a superpower conflict, confirming that continental preparedness was as strategically essential as forward deployment in the architecture of Cold War defense.